Okay, the next thing we're going to move to is some application stuff. And so we have average velocity. These are just some definitions, so we're not going to spend a lot of time reading through this, but is the velocity is the distance divided by the time. Suppose you have a point P on a coordinate line, then the velocity of P at time t can be defined by the limit of s of a plus h minus f of a s of a divided by h. The limit approaches h approaches 0. Provided the limit exists, this is called the instantaneous velocity of P at time A. So this is similar to what we were just looking for, but this time we're going to talk about it in terms of velocity. And then we have a function that's defined on an open interval, the average rate of change of y with respect to x on some given interval. So this time we're looking at an interval a plus h. It's defined here, and the instantaneous rate of change is going to be defined by taking the limit of that, provided the limit exists. Okay, so let's see some examples that will work using these definitions and applications. Okay, so find the average velocity of P in the following time intervals. So they give us some time intervals. They tell us our function, and then they say find the velocity of P at time t equals 1. Okay, so you can see when we have points at interval times, we have this limit, so we'll have that written down. So we have the limit there. And we want to calculate, let's work with this first interval. So I'm going to denote that 1, 1.2. Alright. So if I'm going to plug that in and want to evaluate this, I have, at that particular point, this a plus h, this is the point that's further along in the line. So what would be s evaluated at that? It's s evaluated at the 1.2 time interval minus s of a. So you're going to take the larger interval minus s of a, and so also in our s values we'll have 0.2, 1.2 minus 1, so we'll evaluate those. When I evaluate this s at 1.2, it means I plug in 1.2 everywhere there's a t in that. So let me represent that in red. So it's going to be 2 times, now I'll put 1.2 minus 3 times 1.2 squared. Now I'll subtract. Now we want to evaluate s at 1. So same thing, but this time we evaluate it at 1. So that would be 2 times 1 plus 3 times 1 squared. All over 0.2. Okay, so we'll calculate that, and you should come out with negative 4.6. I'll give you a few minutes to check that. Okay, so while you're checking your calculation there, notice that this red part is s evaluated s at 1.2. I just added this in up here just so you could see that there, and s of 1 is here. So if you just need it to see this extra scratch work, maybe that's helpful to you. Okay, so when we do the second interval, we have that here. We'll have s of 1.1 minus s of 1, and then you subtract out in the denominator. Okay, I had a good question. They just said, will this second number in the interval always be our a plus h value? And when we look at it like this, the value of our average velocity is the distance over the time. This is distance in respect to, we have our position function, and if this is a, this is just a plus h, some value of a with h added. So when we're trying to find the distance, we need to know S of A minus S of A, S of A plus H, excuse me, and subtract out that. That gives us the distance. And the H right here, what's represented, is going to be the time. So the difference in the time interval, that's why we're subtracting the seconds there. And so this calculation itself is going to give us our average velocity. This is S sub 1.1. Then we want to subtract out S sub 1, which we already had up there, so that's the same. But this time, what's our time value? 0.1. And we get negative 4.3. Okay, and likewise on this last one we evaluate, we'll get negative 4.03. And so that's part A. That's with different time intervals, and given this function, we can calculate the average velocity. The next thing we want to know, velocity of P at time t equals 1. So suppose the point of P moves along the coordinate, we want to use this. So first thing we want to do is calculate the velocity using this, taking the limit. Okay, we want to use our function and calculate this. So when we evaluate it at A plus H, what's that gives us? That gives us 2A plus H minus 3A plus H squared, right? S of A plus H plugged into this would be that. And I have minus the original S sub A. So that would just be 2A minus 3A squared all over H. Okay, so it's just 2A plus 2H minus, we would get 3A squared. If you need to go off to the side to simplify this, you may. And then here we would have minus 2A, so that was our minus 2A, and then what, plus 3A squared all over H. Now let's look at what cancels. So a 2A, and what else? A 3A squared. And then we look at our remaining terms. This has an H in it, this has an H in it, this has an H in it, and this has an H. So you can factor out an H and then simplify those. So let's go ahead and factor out. If I factor out my H, I would have that minus 6A minus 3H. So then we can factor out in H, and we would have 2 minus 6A plus minus 3H, almost put plus, minus 3H. Okay, we evaluate the limit, and what is the velocity? What's the limit as H approaches 0? So it's just going to be 2 minus 6A, but it told us at a particular point, right? Didn't it say at t equals what? So they also told us that t equals 1, and in this case our A is going to be 1. So we would get 2 minus 6, which is going to be negative 4 centimeters per second.